Hello and welcome back to my second episode tutorial about X-Plane, which is sending data to X-Plane. In the last video we talked about receiving data from X-Plane, which is about any data you have in X-Plane, such as altitude, location, position, elevator command, and so on. In this tutorial we're going to talk about sending data to X-Plane, which is somehow commanding X-Plane, such as changing the control surface position, retracting or opening the landing gear, or overriding the position, and any other data refs that is writable. Remember, in the last tutorials we talked about data refs. This is the same concept. Each data ref that is writable, you can change it here from it. And if you very important note, if you haven't watched the last video and have no idea about X-Plane data protocol, pause this video immediately and go back to the last video, which is receiving data from X-Plane, because in this video I'm not going to talk about the protocols. I'm just going to refer to what I said in the last video. I somehow did the teaching in that tutorial, but in this one I'm going to use those concepts. I'm not going to go through all of the protocols and what is happening inside this protocol. So if you haven't watched this, watch that, pause this video, go watch that and come back here. Okay, let's go without wasting any time. Let's go to X-Plane. This is maybe the third time that I'm recording this video because I have no idea why Camtasia stop responding each time. I hope this time nothing happens and the video will be safe and sound. Okay, let's go. Let's remember what we have done in the last video. Just let me make sure that Camtasia is recording. Yes, it is recording. Okay. This is a tutorial about the last. This is the page for the last tutorial, which is about receiving data from X-Plane. I talked about the paper out there in ResearcherGate from Adriano, Bittar, and the other projects about this in X-Plane 10, and some references here. I will put the link for all of this description in this tutorial as well. And there are two pages here, the GitHub page and the MathWork page. Both of them will be updated. By the time you see these pages, I will update these pages, because right now there's only the file for getting data from X-Plane, and after this video I will put another file for sending data to X-Plane in the GitHub page as well. So you can download the file from GitHub page here. And if you have any questions or comments or any advice for the next tutorial, you can put it in the comment section. Remember to like and follow if you like this concept. Okay, let's go to work. I start with this very quick refresh. Now this page from SimVim. There are different type of data communication with UDP here. You can see there's command, character, data, and data ref. I talked about different methods in the last videos, and I told you that the most common one is the data, and we are going to use this one as well. Sending data is just the same as receiving data, but this time, instead of getting the data and think what to do with that, we are going to create that data. So the packet that we were receiving from X-Plane, this time we are going to create that packet and send it back to X-Plane. Very simple. If you understand the concept of this protocol, it's very simple. It's the easiest thing in the world. Or at least it's not the easiest thing in the world, but it is easy. Okay, remember, just for a quick refresh, each packet has a header. This is a constant in ASCII format. See, this one 68, 65, 84, 65 in the ASCII table. If you like and go and check, you will find that it is associated with data with capital letters, Delta, Alpha, Tango, Alpha. This is the header identifier. The next one is the index of the group of variables that we are using. If you have seen the last video, it is very simple for you. Each of these, you see, each of these is a group of data. These green blocks, group of data coming from X-Plane. And you should have known the concept of the byte arrays, floats, singles, and so on in the last video. You know that for the communication we should use byte variable, but with the calculation we can't use byte. We used to use single and float. So single is 4 bytes. Each single or float number is 4 bytes. So you can see this one green square is a float number. This can be anything, elevator, aileron, position, anything. And this float number is created by 4 bytes. These are the 4 bytes, right? And each byte is a number between 0 to 255. So 166, 138, 1671 will be converted to a float variable. And each group has 8 values here. Each group has 8 values. So 8 of 4 bytes is 32 bytes. So each data packet is 32 bytes. And we add the 4 bytes for the index, becomes 36, and 5 bytes for the header, it becomes 41. So each a data packet that is sent to X-Plane, it is at least 41 bytes. It can be many more. And the only thing that remains is this one, this single 60 here. In the X-Plane protocol, as you remember, after the 4 bytes of the header, there is arbitrary byte here. It can be anything. At least I think it can be anything, but I always put a 0 there. For example, here it's 60. What is 60 here? This sign. I will put a 0 there. It's usually 48. Doesn't matter. This is the very quick refresh. And the index. What is index value? Index is an index number for your group of variable. For example, here it says that group variable of trim, flap, slats, and speed brake is 13, and only the first one. This one is a group of 4 bytes. It's 131,000. It can be converted to arbitrary float number. That's not important here. Okay, and where you can get this index? Very easy. You can use the documentation in the X-Plane website, or the easiest way is go to here, X-Plane settings, data outputs, and look here. For example, joystick, aileron, elevator, rudder, index number is 8. Very easy. Okay, that's it. Everything you should know about the protocol is here. Let's go to our Simulink. This is the file that I'm going to put in the YouTube and GitHub page. After publishing this video, you can access this access to this Simulink model. What this model do is it's command elevator, aileron, rudder, and throttle. This is associated with surface controls and throttle control. Let's see what is happening inside this model. Let's start from the end, the UDP send. This is the purpose of this. Obviously, this is the purpose of this tutorial. We are going to send something using UDP. So we are going to use from the model manager, Blackmagic library browser, or you can just type here and find the block here. UDP send. The first item is in the setting is the IP, because we are going to use on the same computer. Everything is happening on the same computer. So we put the IP address of the local host here. For the remote IP port, again in the last video I talked about the concept of the communication in UDP. So just to tell you the answer, we are going to send on this port. So X-Plane should listen to this port, 4900. So in the setting, we should set this port number, setting of X-Plane, the network here. The port that we receive on, we means X-Plane. We receive on is 4900, and we are going to use the legacy. I don't know why, honestly. That's it. Now Simulink can send command to X-Plane. The next step is byte pack. In the last tutorial, if you remember, we had byte unpack. Here we need byte pack. Everything is the reverse form in this tutorial. As I told you, the communication inside computer, any communication such as UDP, TCP, serial, TTL, and any other form of communication, the data should be transferred byte by byte. So a series of bytes is being sent. A river of bytes is sending to the port. So here the values, for example, the elevator is not a byte, it's a single value, it's a float value. So we should convert it to byte and then pack it together to become a series of byte array. So we should change, in the last video when we had byte unpack, you remember that the input was a series of bytes and output was our choice. We could select what kind of data we are going to parse, what kind of data we are going to get from that river. Here is the order is reversed. We have arbitrary data here and we convert it to byte pack. The first one is header, which I have set a byte array. I will talk about it in this part. Only just to show you here, the header is byte array. The next one, 48, is, as I told you, is a reserved arbitrary byte. I put 48. 48 is associated with the byte 48, not zero character, not zero value. It is a character 0, but the value is 48. You should create a constant block and come to signal attribute and put a uint8. Uint8, as I told you, is the same as byte. But if you don't change it to uint8 and put it something like single, it won't be a 1 byte variable anymore. It will be 4 byte at least if it is single. But we don't want that. We want it to be only 1 byte. So we put it uint8 unsigned int 8 bit, which is a byte. The next two parts are the data that we are sending to X-Plane. These two can be as many as you like. I have just changing 2 groups of data. You can change 4 or many more data groups as well. But if you click on the byte pack, you see that these are the input port data types. You should tell the block that what are the data that are coming to you. As I told you, the first group as uint8, second one is uint8, which is byte, and the last two, which are the surface control command and throttle control commands, are single values or float values. So they should be changed. This block does it automatically. It converts that to bytes and then pack it together. That's done. Let's go to the main part, which is this MATLAB function. This is very easy. It's only this 3 or 4 line of code, but you need to understand the concept. This is the most important and most challenging part. You should understand what is happening here. And I hope you're familiar with the syntax of function implementation in MATLAB. We have a function that the input parameters are elevator, aileron, rudder, and throttle. And the header, surface control command, and throttle commands are our outputs. Okay, here we are going to create our packet. See here? Here we are going to create this packet. The first one first, header. We first create this 4, 68, 65, 84, 65. Here 68, 65, 84, 65, and for the last arbitrary one I have added manually here. And next one is surface control command. Look at here, just for a quick refresh. We have 8 single values and 1 4 bytes of index. This is somehow looks like a single. You see this 4 bytes, this is 4 bytes. This can be looked as a single. It is not a single value, but it can be looked as a single value because it's 4 bytes. So we can have 2 methods here. The first one, which is more beautiful coding, is like this. I typecast the uint8 of 8000. As I told you, you should go to the setting of X-Plane here and find the group associated with the control surfaces. Control surface index 8. So the index will be 8000, and then you can typecast it to single 8000 and put the single value here, and then you have the real values here: elevator, aileron, rudder, and others no commands. I will tell you what is no command. This is no command. Imagine you are going to change the elevator with your command, but you are not going to change the aileron. You are not going to change the rudder. You only want to change elevator. So for those variables that you don't want to change, you just want to change elevator, you give the value for elevator. For the others that you don't want to change, you don't intend to change them, you should put this reserved code, which is -999. This is reserved code by X-Plane, and it is a single value, 4 bytes. So for these values that we don't know what are they, maybe they are available, maybe they are not, we don't want to change them. We just want to change elevator, aileron, rod. That's it. And what is this one? As I told you, we will create the surface header here and copy the surface header as a single value here. This is very more beautiful way of coding, but I don't know. I face with errors. I have no idea what is happening. I think it's because of data conversion. When Simulink is running and the simulation is working, the data conversion is different somehow. When I copy this line here and run it, it happens and it works. But when I do this and run the simulation, I face with errors with type, the type and the dimensions are not the same and something like that. So if advanced MATLAB programmer is watching this video, if you know what is happening, and I somehow know what is happening, but I don't know how to fix it. If you know a fix for that or a better idea, please give me in the comments, and I thank you in advance. So forget about the beautiful coding and get back to the ugly coding, than the hard way of coding. So I did this line manually. I went to the documentation and see that the index value for the surface header is 8000. So I converted to a single value, a 4-byte single value, by manually to this value. And I come here and copy this value, copy and paste it here on the first one. This is a crazy small value, 1.12 to the power of -44, but it doesn't matter what's the value. It matters what this value when it's converted to a byte, which will be 8000. So if any of you have any idea of what's the better way, please tell me and I will change it in the next version. Okay, let's come to this part for the ordering of this. By now you know that you have selected the group for joysticks, but you don't know the orders. I gave you a two-way in the last video. The first one was coming to this page, search for the one that you have selected and see the orders from here. But in this page there are some errors, there are some, I can't communicate good with this page. It's good, it has description, but it's a little hard to find the group. There is no index number here, and I saw some bugs, or maybe I don't understand it. Some of them are 9. All of the groups should have 8 values, but some of them have 9. For example, here angular momentum with 3. Maybe these are together. I don't understand, or maybe I don't like to understand it this way. So I want an easier way for that. The easier way is you come to this setting, any block that you want, for example 8. And remember, you should check it in network UDP here so you can get the values using network communication. Maybe if you don't check this one, you can't send the command to X-Plane. I don't know. I think you should be able, but I don't know. I haven't checked it, and I think it doesn't worth to check. Just don't waste your time for see how it works. How it works. Only thing that matters is how it works. How to make it work. It doesn't matter if in any exception situation how it will react. It doesn't matter. Just check it very easily. Here in the first one, it is showing cockpit. When you check this, see here, just look here when I click. Some data is being added here. Click on done and go to here. This is this block. You see there is each line of this is a group of variables, a group. And each group, as you remember, has 8 values. 1, 2, 3, 4, 5, 6, 7, 8. But in this airplane, right now we have a Cessna, and Cessna is doesn't have many control surfaces. Maybe if you have a VTOL, you can see where is our airplane. I don't know what the Cessna is. Can you identify the Cessna here? I can't. It's somewhere here. Okay. Cessna, if you have a VTOL, for example, or an aircraft with movable horizontal stabilizer, you will find some control surfaces here as well. For example, movable swing, variable swing, and many other values. But in this Cessna, we have only elevator, aileron, rudder. So other values are not available. So what should we do? We put -999 on that. Very simple. We don't care what are they, and we don't want to change them. So only the first three items matter: elevator, aileron, rudder, and the order is the same, just like this: elevator, aileron, rudder. And in our MATLAB function, we do the same: elevator, aileron, rudder, and the other ones, no command. Done. The surface control command packet is ready. We do exactly the same for throttle command. Throttle command index, again, you can have a beautiful way of coding and ugly this way. Throttle header is 25000. You typecast it, copy it, put it here, typecast it here, and you get the throttle header, which is this one. Copy it to the first item here, and the other one, 8 numbers. Again, you can do the way here and show the throttle here. This is this group. I already done it. And you can see in Cessna there is only one here, throttle 1. If you had a Boeing 747, just like this, here you will have 4 items here, different throttle for different engines. So right now that we have a Cessna, there is only one here. So simple. What should we do? Come here. The first one is the index value, and the other one is throttle value, and the other ones are no command. Very, very easy. For example, if you wanted to change some other commands, such as landing gear, such as flaps, and so on, what would you do? You just copy one of other this, change the name to, for example, landing gear or flap or any other thing that you want. Just remember to check if it is right. Get the number of the index from the settings or documentation, typecast it to the single conversion, and put the value here, and then go and check the ordering here and put the values here. Very simple. Right now only throttle and control surface is enough for us. Save it, come back to our model. Okay, almost all of the job is done here. We have covered this type, and the easiest part is this, the input. You see, just for demonstration, I'm just giving a sine wave because you can see the result easier. Sine wave to all of these variables: elevator, aileron, rudder, and throttle. And elevator, aileron, and rudder are a value between -1 to +1, just like sine wave. But the throttle is between 0 to +1. So I put a saturation block here and set the lower limit is 0 and the upper limit is 1. Very simple. And one more thing, one more important thing. Maybe by the settings in your Simulink, the data is coming out of this sine wave be double. And in that case, the concepts here may become, I don't know, wrong. So you should change you should do a data type conversion. There's a block called data type conversion. You can find it from the library. You put it here, and in the setting, you say the output data type is single. Very simple. And here's a piece of cake. Everything is done. And the last one is real-time synchronization. In the last video, I talked about that. I put 0.02 seconds for the sample time. And I told you what will happen if you don't put this here. Your simulation won't be real time. That's it. Let's go to X-Plane. I hope I haven't missed anything. We talked about the UDP send, byte packs, the data is here, what is happening inside the MATLAB function. So everything is covered. Let's go to X-Plane. And here is Tehran. this is a default scenery for Tehran. Maybe in the next videos I'll put more detailed scenery. So just for those of you that you want to know, this is Tehran, this is Mehrabad International Airport, Mehrabad Tower, this is Milad Tower, and Azadi Tower, the iconic Azadi Tower near Tehran, Iran. That's it. Just for your geographical common knowledge. That is Air Force Boeing 747. Okay, enough. Go to our beautiful Cessna. Come here. That's it. Right now I have command on all of this. I can tell you. Everything is on my control. The joystick or any other. Okay. Right now we want to control these things with SimVim. Come to our simulation. Put infinity here because we want the simulation to go on forever. Just when I click the pause, and we put it on normal mode. Then we run the simulation. I hope it works. Yes, it works. Come to your screen, you can see yes. Everything is working with sinus, like sinus wave. Ailerons, elevators, rudders, and throttle. You could also change the mixture as well, but in that case the engine would turn off. And you can look the airplane from outside, ailerons, elevators, rudders, and you can see the left turn tendencies when the engine is powering. The airplane is somehow trying to rotate, but the parking brake is set. Okay, for the last part, I have put this display blocks here. Okay, we have 4 display ports here. These are only for debugging and tutorial purposes. After you understand the concept, you can delete this one. This is header, the constant header 6864, 8465, then append with 48, and this one is surface control command. Remember that crazy small number to the power of -44. This is the surface control command in single format. You can see this is the values between -1 and +1. It's changing elevator, aileron, rudder, and the other one is -999, which is unchanged. For throttle, again, only the first one is changing. First one is the crazy number for index, and the first one here. You see it stops on 0, then goes up, +1, and again comes back. And the other one is unchanged, -999. After all of this, go to the byte pack command, and all of them convert byte array. As you can see, the final result. This is the one packet that is being sent to X-Plane. You can see 68, 65, 84, 85 associated with Delta Alpha Tango Alpha, and 48. After 48, this is the first value, which is surface control command. Remember the index 8, 8000, then the values. Each of these values, for example, these 4 is associated with elevator. If you convert these 4 by say 1 float number, it will be the value that you see here. After that, again 4 for aileron, 4 for rudder, and the other one is -999. For example, this 4 is 1 -999. This one is again 1 other -999, and so on until this one, 25. This is the index for throttle, 25000. Then the throttle command and -999 that will place for the unchanged one. I think I talk about everything here. This is how you can send data to X-Plane. That's it. Let's see from our. That's it. Right now you have great power in your hand. You can get data from X-Plane just like a sensor, for example the attitude, momentum, or gyro, and you can send back commands to X-Plane. So you have everything you need for control analysis, control simulation. In the next video, I don't know when. I'm trying to do it as soon as possible, but I don't know when. In the next video, I'm going to to a software in the loop processor, build our own autopilot. For example, we let this Cessna fly in the air, and we create a PID controller that it's getting the value of the pitch and angular velocity in pitch channel, and with the PID controller we send command to elevator to stabilize our aircraft, and we always maintain the pitch at for example 0 value, or we create an altitude hold mode, for example. These are the ideas that we can make in the next video. I don't know when. I'm very busy with my studies, with my career, with my job, and I'm just creating this for the sake of improving the X-Plane community. Many of you requested for this video. I hope I could have helped you. And if you have a project, if you need help, you need a partner in your project, I can work you in that case. I can help you in those works as well, in simulation, control analysis, aerodynamic analysis, and anything related to that. So if you have any suggestion, comments, question, feel free to ask me in the email or in comment section. And if you like this, please like, subscribe, and share it if you don't mind. And that's it. Happy flying and happy coding and happy simulating. Thank you very much. Goodbye.